All right, let's do a couple of problems. So let's sketch. This is number 12 in the section. Let's sketch 9x squared minus y squared plus z squared equals 0. Okay, so now what I'm going to do is I'm going to look and I'm going to be like, well, what's the symmetry? Which two can I sort of make a symmetry? This one's actually not bad. Y and z sort of are replaceable. Well, no, not really, because they're different sides. So they're not. Good. That's even better. Because what I'm actually going to say is actually the symmetry is in x and z, which not really because of this 9, but we'll get to that. So what I'm going to do first is I'm going to be like, I'm going to get rid of that 9. So I'm going to say, you know what? Let's let u equal 3x. Okay? So then I have, if I had u squared minus y squared plus z squared equals 0. Okay, now I have a symmetry, right? U and z are symmetric. Okay, so I'm going to graph first y squared equals u squared plus z squared. What is that? That's a cone, right? That's a cone. Okay, y is sort of the special one. Okay, so what I'm going to do, I'm going to draw it. Let me draw it here in that color, whatever that is. Okay, so it's going to be like so, and a cone, right? Even get rid of the u coordinate there. Okay. Now, what am I going to do about that u? So let's go ahead and now make it an xyz. Okay. I'm going to basically do the same sort of thing. I'm going to go back to 9x squared minus y squared plus z squared equals 0. And it's basically going to have the same sort of shape. Except for now, sort of I'm going to exaggerate just a little bit the x coordinate. And actually, I'm going to exaggerate it more than a little bit just to sort of really show what's going on. So I'm going to exaggerate it to be a little bit bigger in that direction. So it's going to be like, let's see. Nope, bad. That's terrible. Okay. And all I'm basically saying is that, hey, you know what? Yes, it does rotate around this y-axis, but the rotation goes out a little farther when I do it in the x direction. Okay, so it's not quite a circle. It's more like a ellipsoid. Try it one more time. Let me try it a different way. Maybe, somewhat. Okay? It's also going to do the same sort of thing on this side. You guys are lucky because I'm probably not going to ask you to draw these things like that because I actually never really do. Okay? All right, let's try another one. Let's take, this is number 26. And it is 4y squared plus y squared plus 4z squared minus 4y minus 24z plus 36 equals 0. So we're going to actually reduce it to a standard form and identify what kind of surface it is. Okay? So I'm going to do what I would normally tell a pre-calc student to do. Let's put the x terms together, the y terms together, and the z terms together. Oh, this should have been an x here. Okay, so 4x squared, there's no other x terms, plus y squared minus 4y. I'm going to put a plus with some space because I'm going to be completing the square. 4z squared minus 24z, leave a little bit of space with a plus, equals, I'm going to put that 36 on the other side. Okay, now what am I going to do to complete the square? Here, I have to add 4 to both sides. Right? I take half of this 4 is 2 and square it. Here I'm going to take half of 24, which is 12, and square it. That's 144. Okay, so I get 4x squared plus y minus 2 squared, should have been a plus here, plus, should have probably taken that 4 out first. Let's do that before I complete the square. So let's do 4 z squared minus 6z. And right now we're here at negative 32. Now here, like I said, I screwed up, but I caught it. What do I have to do to complete the square? I have to add 9, right? So 4x squared plus y minus 2 squared plus 4 z squared minus 6z plus 9 equals negative 32 plus, why did I write 39? Negative 32 plus 36, right? Because I have to add not just 9, but 4 times 9. Okay, so I get 4x squared plus y minus 2 squared plus 4 z minus 3 squared equals 4. Now I'm going to divide out the 4. Okay, so I have a 1 on that side. So I get x squared plus y minus 2 squared over 4 plus z minus 3 squared equals 1. So this is a ellipsoid. And it's centered at 0 to 3. And I'm not going to draw it because no. All right? Because no one in my room here wants me to draw it. Let's put it that way. All right? All right, I'll see y'all. May do one more video. I'll think about it. If not, the next set of videos.